Hello everyone, let's look at Leetcode question 2810, faulty keyboard. Your laptop keyboard is faulty, and whenever you type a character I on it, it reverses the string that you have written. Typing other characters works, as expected. So you're given an input value string S, and you type each character of S using your faulty keyboard. Return the final string that will be present on your laptop. So we'll go into depth with these examples, but as you can see, the first is S equals string. And everything is normal as you type str, but then the moment you type I does not print, and instead str is flipped, and G follow as normal. For pointer, there's two flips, and the constraints are that S length is between 1 and 100, S consists of lowercase English letters, and S of 0 cannot be equal to I, so the first character cannot be an I, because you'd be flipping nothing. To solve this problem, we're going to use slice notation, which is used to extract the substring. In this example, S is equal to fudge. And using the slice notation, we see that 0 to 2 is FU. The last index value, 2, is non-inclusive, so therefore we want the index values of name at 0 and 1. That's FU. Name 2 to 5, that means indices 2, 3, 4. D, E, D, G, E. And this one, it says there's no initial indice, and then it ends at 4, non-inclusive, so it's from 0 to 3. So F, U, D, G. And here there are no end and start index values for the name substring, so the slice notation does not change anything. And for this final name, we have 1 to -1, and this just means we start at the second index value, and we end at the second to last index value, so it becomes 1, 2, 3, so UDG. To solve this problem, we first define the word array as an empty array. We choose an array because it has a convenient syntax of reversing its values. So we iterate through every character in string S. If the character is equal to the faulty key I, then we reverse, using the syntax word :(-1). Otherwise, if it's not the character I, it's a normal word, and we could simply append the C character to the array. We do this looping through every character, and finally return the word .join word. The .join converts the word array to a string, and these double colons indicate that there will be no separating factors between the elements of the array, so we return the string as it's supposed to. Running through this first example, the first character is S. For C and S, C is not equal to I, so word.append C. T, for T and S, also not I. R, and finally I. I is equal to C, word equals word, :(-1). STR becomes RTS. Then we go to the next character. Notice that the I is not appended. N is the next character. It's not equal to I. We append it. And G appended. Next, we return the .join, so this array becomes a string. It is now RTS NG, our final output. Let's look at this example. Pointer. Okay, so we start with P. P is not I, simply append to the word array. O is not I. I is finally the character C. Word is equal to word, :(-1), so PO becomes OP. I is not added to the output. We go to the next character, it's another I, so OP becomes PO, so it's just flipped back to its original position in the array word. The next character is N, simply appended, word.append C. C is equal to T, C is equal to E, and R. If we exit the for loop, we've iterated through every character, and we can return the string equivalent of this array word, which is the string pointer, something like that. Okay, so let's check the solution. See if it even runs. Okay, it works. Great. Very nice, concise solution. What is the time complexity of the solution? There's one for loop. It looks like it's O of n, where n is the length of the input string s. This is because we iterate through each character in the string once. The space complexity, that is actually O of n as well. It's O of n because we create a new list to store the characters of the final string. The size of the list will be equal to the length of the input string in the worst case. That's it for this video. Thank you for watching.